Okay guys, so now we're going to go through a problem for similarity with a shape that's on a triangle. And today we're going to be talking about similar figures, reduction factors and enlargement factors. And in particular, we're going to be talking about the scale of these shapes. Now the scale factor can be found by dividing any pair of matching sides. Now looking at these shapes here, I can see that the angle there between the arc and the x is the same as the angle there with the arc and the x there. So I can say that 39 over 52 is a scale that we can use. So if I write that scale as 39 over 52, and let's say for argument's sake I label this side A, B, and that as C and D, then I can say that side AB is the same as side CD. Now, you don't need to worry about too much about the terminology there, just worry more about the numbers there. 39 and 52. Now, if I divide both of those by 13, I get a scale factor of 3 over 4. Now, this scale factor here is what we call a reduction factor. Why? That's saying that one side is 3 parts and the other is 4. 3 parts to 4 part. Now, if you remember ratios, we can simply go down to 1 part and we can then calculate what the other parts are. So this here is what we call the reduction factor. Now, the opposite of the reduction factor is the enlargement factor. And the enlargement factor is quite simply the opposite, which is, if that's 3 over 4 there, then it's going to be opposite of 3 over 4, it's going to be 4 over 3. And that 4 over 3 there is called the enlargement factor. And that's how simple it is, guys. It's just as simply as you finding out what is the ratio or the same side, putting it as a fraction, simplifying that fraction, that gives you the reduction factor, and then flipping it over gives you the enlargement factor. Now we're going to go through more in regards to how we use the reduction and the enlargement factor in another video. This video was simply to show you how we find the reduction and the enlargement factor. Now I'm going to give you guys a quick question to try yourselves, and let's go through the answer. I'd like you to pause the video, go try and do it yourself, and then we'll go through it again. So we're going to draw two triangles. They're obviously not going to be the scale, but we can only use the variables that are given. So let's say, for example, this is x, this is 24. We can label this as 20 and 30, and we can label this as 28 and y. Now, in order for me to say that they are the same, I can label these as such, and I'm going to get you guys to pause the video and then we'll go through the answer. Okay, let's go through the answers. Now, let's, for argument's sake, this is A, B, C, and this is D, E, F. We can clearly state here that triangle A, B, C is similar to triangle D, E, F. And in saying that, here we're saying that side A is the same as D, B is the same as E, and C is the same as F. Now in saying that, we can clearly identify that there are some numbers that we can use for our enlargement and our reduction factors. And there we have 20 on that one, and we have 30 over here. So if we write that as a fraction, we have 20 over 30, which can be simplified to 2 over 3. Now this, remember, our 2 over 3 is our reduction factor. I'll just write RF there. And the opposite, which is 3 over 4, 3 over 2, is our enlargement factor. So, wasn't very hard there. We just find two values that are matching, we put them as a fraction, and we can figure out what is happening. So, if you have any other questions, please jot it down in the comment section below, or watch the other videos on similarity for similar types of questions.